Hello everyone, welcome you back to another video. So in the series of algorithm, this is the 7th or 8th class. Some of the asymptotic notations we are discussing. So today we are going to discuss about theta notation. So this is the third notation we are discussing. So in the previous classes you can find it out. We have discussed about big O and omega. So this is used for the worst case. This is the worst time taken by an algorithm to solve a problem. But omega represents the best case, well, the minimal time taken by an algorithm to solve a problem. So these things we have discussed in previous classes. If you haven't seen, then you can go and check it out. Let's coming to theta notation. Focus on the definition. Fn and Gn are non-negative functions, right? Non-negative functions. The function f of n equals to theta of g of n if there exists a constant c1, c2 and n naught such that c1 into gn is less than equals to fn is less than equals to c2 into gn for all n greater than equals to n naught. So if you don't understand, then don't worry, you can check here the graph. So what we are going to find out, in the simple word, I want to say something. We are going to find out the asymptotically equal functions. Asymptotically equal, I am not saying the function value must be equal, but the asymptotically equal function we need to find out in theta function. Actually, while you have read about big O and omega, I told you which term is inside the big O that will be asymptotically greater than the fn. While we are reading about omega, I told you if this function must be smaller than the fn. But now I am saying you that while we are reading this theta function, so this f of n and this g of n must be asymptotically equal. But if you don't know what is asymptotically equal, then you can watch the previous videos to get more information about it. So this is what we can say in simple word, right? You can see here what is this, this is the fn and this is ct1 into gn and this is c2 into gn. So fn is lying between gn. This graph represents fn and gn are both asymptotically equal. So this is what we can conclude from this graph and this definition. Let's go for some questions. This is 2 power n plus 3 and this is 4 power n. Actually, asymptotic notations are used to compare two functions, and here in the question you need to find it which function is greater, which function is smaller, and if both are equal, then we can represent it through theta function, right? Otherwise we can use other notations like big O and omega. So here the important term is 2 power n and this is a constant, so this will not vary with the value of n. This is the important term, so I can write it as 2 power 2n, right? So 2 power n plus 3 must be less than equals to 2 power 2n, because here the exponent is n and here the exponent is 2n, right? So this will be greater. Can I write it through theta function? Absolutely no, because both are having asymptotically different values. So I can't write it like 2 power n and 2 power 2n are both are asymptotically equal. I can't write it. Let's see here. 2 power n square, this is the significant term n square, and this is n. These both are polynomial terms, and we can see that this one will be greater than n. I can also represent this these fn and gn, like suppose this is fn and this is gn. I can create a relationship between these two using theta function, because both are not asymptotically equal. I can write it using omega functions or big O function, but not using theta function. See here, this is the thing and this is the thing. Those who have not understood what is asymptotically equal, you can see here that this is n square, the significant term, and this is n square. These both are the polynomial terms. These two functions will give different value with different value of n, right? Because this is the n plus 2 term is adding here, so this will add some new value to the n square, and you can both get different value for these two functions. But asymptotically I can say these are equal, because the significant term I can write it as order of n square and I can also write it as order of n square. Asymptotically both are equal. So now I can write it as f of n equals to theta of g of n. So in the previous classes you have seen that some of the functions I can write it f of n equals to order of g of n and g of n equals to big O of f of n. I can write some functions in previous videos. You can see that if such cases arises, then it implies both are asymptotically equal. In those cases I can write it f of n equals to theta of g of n or g of n equals to theta of f of n. Same applies for the omega also. If f of n equals to omega of g of n and g of n equals to omega of f of n, then both are asymptotically equal. So I can write it as f of n equals to theta of g of n. So let's come to this question. This is n square plus n and this is n cube. Both are not asymptotically equal because this one will be definitely greater than this one. Let's come to here. So this one will be greater than this one. So I can write it using theta function. Here you can see that nq and nq both are equal. So I can use theta. See here. 3 power n plus 1. You can use the properties 3 power n into 3 power 1. I can write it. 3 is the constant term we are multiplying, but 3 power n is the significant term here and 3 power n is also significant term here. Both are equal asymptotically. Here also I can use theta. Look at this. This is 3 power 2n and this is 3 power n. Simply we can see that 3 power 2n will vary more than 3 power n. This value will be greater than 3 power n. This is n plus 1 power 100 and this is n power 100. With expansion of these terms, we can get numerous number of terms, but the significant term will be maximally 100 because using that formula ncr x to the power n minus r and y to the power r, we can expand this, but the maximum exponent of n we can get as 100. So both are asymptotically equal. I can use the theta function now. See here, this is n factorial and n power n. In the previous video I also told you about this. N power n will be greater than n factorial, but log n factorial and log n power n both are asymptotically equal. Please note this thing. And about this part, n plus k power m, here k is a constant, so using that previous questions you can say that the maximum exponent of n can be m only. So here also n power m we are getting, so both are asymptotically equal. Then we can use theta as the notation here. I think you got clarity about all these notations, all these three notations. Please practice some questions from some workbooks. Those online PDF are also available, and please join our Telegram group. If you have any doubt regarding your planning or you are feeling low, you can just ping me there. Thank you and all the best.